Hello, my name is Hunter Singh, and I am an undergraduate student studying atmospheric science. And today I will be discussing a meteorological event happening in the Middle East that will cause detrimental rainfall and the possibility of a tornado happening in the Middle East, particularly impacting the countries of the Saudi Arabia, United Arab Emirates, Qatar, Bahrain, Kuwait, and Western Iran. In this picture, we're looking at a negatively tilted strong low pressure system, this trough piercing through the Middle East as it moves westernly across the Middle East. You can see it intensifies around Thursday afternoon and goes through the Middle East and peak basically around Friday midnight, or Friday early morning, Thursday midnight. And as it goes through, it will bring in this rainfall happening through the United Arab Emirates, Qatar, Bahrain, Kuwait, and into Western Iran. And eventually, this system will eventually die out. It will eventually destabilize itself. Friday, eventually, the system will finally move out about Friday night, Saturday, into the weekend. To show a better picture of what exactly will be coming to the Middle East, we can look at the GFS model at 18Z, the precipitation type, or what's going to happen. We can see at around Thursday 2 p.m. in the Middle East, we have this low pressure system developing. We have two low pressure systems developing. One over Iraq, which will bring in heavy rainfall across western Iran, eastern Iraq, and possibly snowfall in eastern Turkey and northwest Iran. Another low pressure system along this cold front, which we will explain later, is expected to move across eastern Saudi Arabia through the Gulf countries to the Persian Gulf into Iran. This will bring in this heavy rainfall. We can see this deep low pressure system has max intensity of 988 millibars, 990 millibars, and this low pressure system between 995 to 1000 millibars as it moves through the Gulf. As we can see heavy rainfall making impact. You can see a cold front along this boundary up here curving, moving faster than the trough itself. Essentially, we will have a occlusion that will bring in snowfall in Iraq, Turkey, and northwest Iran, but really heavy rainfall through Saudi Arabia, United Arab Emirates, Qatar, and Bahrain. As you can see, it moves through. It will continue to make landfall, causing detrimental flooding, rain over well over 3 to 6 inches in United Arab Emirates and Iran, and maybe into Oman. And eventually, we see the system finally decay. Eventually, it will destabilize itself around Friday afternoon into the weekend. Basically, the summary of this whole event is we will have a strong low pressure system, one strong pressure system over Iraq, and a small one that will bring in heavy rainfall through the Middle East, impacting Saudi Arabia, United Arab Emirates, and Qatar. This will bring in the chance of a tornado, as we will discuss the synoptics and the more variables happening in this event. Bring in a chance of tornadoes happening in the United Arab Emirates and Qatar. We will see strong straight line winds over a QLCS, or a quasi-linear convective system, developing across this cold front, which will bring in the heavy rainfall and straight line winds that will well over maybe knock out power, cause trees to fall. But most eventually, the main concern of this event is flooding in the Middle East, essentially cause traffic delays, airport delays, schools potentially canceled, and a change to people's daily lives for that Thursday, Friday, as we'll see rain over again 3 to 6 inches happening in the United Arab Emirates, but as well as 2 to 4 inches in Qatar, Saudi Arabia, and well over 5 to 6 inches in western Iran. We could also see snowfall happening, as we can see here. This blue coloring over here. We can see the snow happening in eastern Turkey, possibly northern Iraq and northwest Iran, having this snowfall in higher elevations or in the valley as well. We see this event basically, it's a rare meteorological event per se. We can see this cold front per se. A cold front is essentially a boundary that pushes warm air aloft and moves cold air below, pushing it upwards, that's able to convect. And that convection is the reason why we have these storms develop, and we have this heavy rainfall. And we'll see why this rainfall becomes huge, why we get to see possibly supercells and tornadoes happening along this cold front. We can see straight line tornadoes over this line, so basically rotations across this boundary. And we'll get to see how exactly will this play out, what variables are important here, and see what's the overall summary of what this event will happen take place in the Middle East. To continue the discussion of this meteorological event, I want to look at what the whole system looks like. And I drew out a cold front, a warm front, and occlusion at this specific time, Thursday 11 p.m. in the Middle East. And in this illustration, we can see this cold front basically at the border of Saudi Arabia and Yemen. This moves across almost like it's basically a curved cold front moving westernly or towards the east, and you see this curve around, go over the Persian Gulf, make its way in, essentially coming to a point between the warm front and the occlusion. And I believe there will be an occlusion because this cold front or this line of storms, this QLCS, is moving way faster than the trough itself. It's pacing at its own rate than the trough itself, and that creates an occlusion, or basically a mature storm. It's basically separating itself. Hence why we also probably have another low pressure system here that will bring in that rainfall over the United Arab Emirates, that will bring in those 3 to 6 inches of rain. And we see this warm front here that's separating temperatures here down in the Persian Gulf, and here in this part of the Middle East, and this is easy drawn because it kind of separates this this warmer air mass here, and we also see from the temperature map from the GFS, there's mostly cooler temperatures here and warmer temperatures here, and this occlusion right here is going to bring in that snowfall in eastern Turkey, north and western Iran, and basically northern Iraq. And we can also, and the reason too is there's a lot of rain bands happening here. This like area of snowfall that would potentially happen. You can see a little bit of snowfall up here too and here, and maybe there's mixing too over this higher elevations. That's why I see an occlusion happening, and it will mature, and this cold front will separate itself, and essentially that causes a destabilization of the low pressure system. And that will eventually come to an end. This event basically staying only Thursday and Friday, particularly Thursday afternoon, evening, and making its way through Saudi Arabia and the Gulf countries, ending around Friday night, and have a calmer environment over the weekend and possibly through another week. Now for this storm in this is a live animation of what's expected to happen. As we discussed, is this low pressure system will mature. Basically 2 of them will start to mature. This one will bring in an occlusion, a lot of snowfall up here in eastern Turkey, and detrimental rainfall on Iran. And the second one is bringing in heavy rainfall in Saudi Arabia, United Arab Emirates, and Qatar. That's where we see this 3 to 6 inches happening over in Abu Dhabi and Dubai. That's causing those traffic delays, potential flooding, and also airport delays too. You see that orange and yellow bringing in that heavy rainfall here, which is a really rare event happening too in the United Arab Emirates. Now, for these storms to fire, I want to look at the vorticity, for example. And vorticity is the local spin of fluids at a point. And in this image I pulled up, but this is the height vertical velocities. These blue values, they're telling us we have high velocities moving vertically, and those tell us we have strong convection happening along this cold front. And as we can see from this image again, we have this this cold front right along this this boundary we can see, and then here, basically the same picture. You can see the blue values. They're indicating we have strong convection in those areas, strong, and also strong vorticity happening too. A lot of those the vertical spin that's able to create uplifts. We have strong uplift motion that will be able to create these storms that form along the boundary, bringing in heavy rainfall. And this doesn't just happen with just the air spinning too. We have high dew points. If we go back to the model, and we go to the dew points here, we can see that before this front moves in, we have dew points well over 19 degrees, 18 degrees Celsius, 22 degrees Celsius. This is enough fuel to bring in these storms happening across the Middle East. A lot of fuel. As these front moves in, we have those strong vertical velocities. Basically the air is able to move up fast. There's basically horizontal convergence happening at those points. And we also have strong vorticity, meaning we have a lot of spin happening. As we have that spin, high velocities, we're able to create this uplift. We're going to have a lot of these supercells, a lot of these big clusters of clouds develop along this cold front, and now we're able to create that chance of tornado happening because of what we have, the CAPE, or the convective aerial potential energy, being well about 1,500 to 2,000 joules per kilogram. That is energy to fuel these storms, and with the ripe environment, we have the high dew points, high temperatures, and as well as the fast velocities in these areas. The chance of tornado is high. Although we are unsure where it could happen, of course the most possibility, according to the CAPE and then the supercell index and the vortices, this region of Qatar, this part of Saudi Arabia, and then the United Arab Emirates, at its where the bigger threat of tornadoes are happening. Looking at the relative vorticity, the high vorticity at 850 millibars, we can see along this front we have high levels of vorticity, or basically strong local spins along this front that will help ignite the storm motions, or basically storm activity along the front. And we look at the 500 millibar, we can see again these little areas of vorticities happening along this front. And from 850 millibars, that's basically kind of near the surface. 500 millibars is that area above the atmosphere where we examine weather phenomena, basically where we can see troughs and peaks happening across the atmosphere. We can see that supporting both the lower levels and higher levels of the atmosphere. And that tells us we're going to have a lot of storm motion, a lot of strong uplift. We have this upper air divergence that's able to lift up this air from the surface, move upward, basically horizontal convergence upward, and diverge out. That basically creates those uplifts of moisture, temperature, and other ingredients such as CAPE, for example, that create these storms along the front. Now you can also look at again the vertical velocities. Again, we can see that strong velocities along this front too, where we have positive vorticity. We have those strong PVAs, positive vorticity advection. We can see that also in the area we have those high levels of vorticity moving through that front, and essentially you can see as we reach that Friday morning, Friday evening, we can see those vertical velocities and those vorticities, they basically disappear. I mean, we don't have strong uplifts for storms to develop. Over here and across the Saudi Arabia, Qatar, and United Arab Emirates, we can see those strong vertical velocities. So we have a lot of the stronger chance of storms happening, and also strong storms that can bring in a lot of rainfall into the area. And to speak of rainfall, before we get to a conclusion of this, I want to look at the total precipitation that will make landfall here. We look at the 24 hours of precipitation that falls. You can see that here, this is Friday morning in the Middle East, around the United Arab Emirates. You can see this area of strong precipitation. A lot of this precipitation makes landfall, particularly in the United Arab Emirates and parts of Oman, impacting Dubai and Abu Dhabi. That will bring well over 3 inches of rain, and possibly over 5 to 6 inches of rain, depending on the strength and how much these storms will downpour a lot of this rain. And it will be a lot of rain that will cause flooding across these regions, such as the United Arab Emirates, Qatar, and Western Iran. Basically, to summarize this meteorological event in my own perspective, this is a rare trough going through the Middle East that will bring in detrimental rainfall up to well over 4 to 6 inches of rain in parts of the United Arab Emirates, Qatar, and Western Iran. It will bring in snowfall in Turkey, Northwest Iran, Iraq, and it will bring in a chance of a tornado happening because of strong vertical velocities, these a lot of local areas of vorticity, this local spin along the front, and even a good amount of cape around Qatar, United Arab Emirates, that will bring in the chance of tornadoes maybe happening. Maybe we could see funnels appearing along the front, or just seeing on radar rotation. If you look at the velocities. Essentially, the biggest problems of this event for the people living there is flooding and power being knocked out because of strong straight line winds from this front that will mostly impacting the United Arab Emirates, Qatar, and possibly Oman. So people need to be careful, watch the news, look at social media to see if there's any updates. People, maybe the city shut down power, or potentially the greater risk of flooding as we get closer to this event. And thank you for watching. This is one of my first meteorological discussions I've done. Definitely will get better. But this is something that kind of intrigued me, looking at the dynamics of the system, looking at the precipitation, the total landfall that's being made, the total landfall that will the total landfall of rain throughout the Middle East, and then what exactly will be taking place, such as a tornado threat, straight line wind threat, and heavy rainfall threat. So thank you.